Okay, for this problem, this equation x squared over 16 plus y squared over 9 equals 1, you will notice that this is the equation of an ellipse. And conveniently, you could see, because there's y squared and x squared, it's not x minus 1 squared or y plus 2 squared. This ellipse is centered at the origin. That's a great thing for us, because now when you want to rotate this around the y-axis or rotate this around the x-axis, you get a shape that you would recognize, in your imagination. It would just be like a symmetrical UFO. So how do you approach this problem? Now, you remember from your class that the way to solve this problem is to add up all of the areas of the little disks. So there's a little disk. Let me change colors. I'll use pink. There's a little disk right there. That's a circle. Like if you looked at it from this direction, if you had your eyes right here and you looked at it from that direction, you would see a circle. This is a slice. I slice another circle. I slice it again, I see a circle. Slice it again, I see. You know what I'm saying? You can just keep on slicing this, and you're going to see bigger and bigger and bigger circles. Circle, circle, circle. And then the circles are going to get smaller, right? You keep on slicing this, you're going to get smaller and smaller and smaller circles. Smaller circles, smaller circles. So we're going to add up all of those circles, all of those little disks. This is the side view of these are the side views of disks. And that's going to be the volume. So how do you find the area of one of these circles? Like, for instance, that one. How do you find the area of that circle whose side view is given by this pink line? How do you find the area of that? Remember that area, okay, back to black. Remember that, okay, maybe brown. Area equals, for a circle, what? Right, pi r squared. Pi r squared. So what is the r for that circle? Okay, so that circle really, okay, I'm going to use an arrow here. So that circle, I'm going to flip it around so you can see it as a circle, right? That circle has a radius, right? I'm going to put a black dot where the x-axis was going through. Okay, so that circle, you see the side view here, and you see the front view here, looking at it from this direction, right here, this direction right here. Looking at it from that direction, you see the side view like this, and there is a radius. What is that radius? Well, the center of the circle is where the x-axis is going. The x-axis pierces right through the center of that circle. So the radius is whatever the y value was for that x. Draw a little. Okay, so I made a little black line going from the y value down to the x. So this is for this x, y equals something. Who's going to tell you what y equals for this x? He's going to tell you. This equation is going to tell you. There's a y here, and there's an x. If we want to know what the y is, we've got to solve for y. So when I'm done solving for y, that is going to be the radius of this circle. Why? Because that is just y, and that's the radius. Okay? Hope that makes sense. All the problems are like this. All of these solve the volume for this shape rotated around this axis and bounded by these curves. These are all like this. So I'm going to solve this for y. So how do I solve this for y? Well, first of all, I'm going to have to get a least common denominator for this guy and this guy, because obviously I have to multiply something on both sides of this equation so that I could get rid of these denominators. But I can't, because these denominators are not together. They're separate, eraser. They're separate. So I need to bring them together. The only way to bring them together is to add these fractions and make it one huge fraction. So the common denominator between 16 and 9 is, let's see, well, I might have to just multiply 9 and 16. So that would be 144. I'd rather not, but it looks like I might have no choice. All right, so 144. So 9 times 6 is 144. Get the pencil back here. All right, so 9 times 6 is 144. Oh, I guess that doesn't need a pencil. That would rather have a brush. Okay, so 9x squared plus, now 16 times 9 is 144. You see what I'm doing here? 9 squared all over 144. Okay, let me show you what I'm doing here just in case you didn't catch that. Size larger. So follow my little square. So here's my square. I multiplied over here 9 over 9. 9 over 9 is just 1, so I get the same thing. 9x squared, 9 times 16 is 144. I multiplied over here 16 over 16. 16 over 16 is 1, so it's legal to do that. So 16 times y squared is 16y squared. 16 times 9 is 144. So I have 9x squared on top plus 16y squared on top. Everybody on the bottom has 144. 144, 144. So that gives me 9x squared plus 16y squared over 144. And that is, oh, sorry. That is not equal to y. I'm just trying to get, I'm just trying to solve for y. So that is equal to 1. Brush, back to the regular size. So that equals, that equals 1, because 1 is over here. All right. Now I can multiply both sides by 144, and that gives me 9x squared plus 16y squared equals, what's 144 times 1? Just joking. 144. Okay. Now I'm going to solve this for y. To solve this for y, of course I subtract 9x squared on both sides. Here, let me get a new page. Okay. So, right. So 9x squared, I got a new page for you, nice and clean. 9x squared plus 16y squared equals 144. All right. Now, by this time, you may already know how to finish the problem. Feel free to leave whenever you like. Just stay for what you need. 16y squared equals 144. So minus 9x squared. Okay. And I'm going to divide both sides by 16, of course, so I can get y alone. Divide this by 16 also. Okay. So now I got y squared is all that jazz. This jazz here. Right here. Was all this jazz. Copy that. Whoops. Okay. Equals. And now to get y alone, I take the square root of both sides. Now, you know that when you take the square root of both sides of an equation, you get plus and minus. So it's really plus or minus square root of all this jazz. But remember, we're not doing this to find y everywhere. We're doing this to find y as a radius. Remember, we're only finding y. We're only doing this to get y as a radius. So for y as a radius, we don't need the minus part. All we need is a plus part, because a radius is just a distance from the center to someplace else. We don't care what direction. We just want the distance. So we don't need this minus thing. All we need is the plus. All right. So the square root of that is all this junk. It's kind of ugly, but you'll notice that here I can take the 16 out because 16 is a perfect square. So this is 16 on the denominator. That means out here I can put it as a fourth, because there's a 4 as a denominator 16 is the denominator. Gone. Did you get that? Of course you got that. You're in calculus. All right. So let me get you another page over here. Okay, so that's the y. So remember, what is y? The meaning of y for us is the radius. Shall I go back to that for you? Just in case you're new to this type of problem. There it is. So we just found this y, and the y is the radius of each of these circles. It's not just for this circle because I'm using x as a variable. So for any x along here, y is going to give me the radius of you, the radius of you, the radius of you, all you guys. And what are these x's around here? These x's go from -4 to 4. How did I know that? I knew that from your Algebra 2 stuff. All right, it goes from -4 to +4. And I'm about to show you. So -4 is right there, +4 is right there. I'm about to show you this. When you have an ellipse equation, the number underneath the x squared is the square of the length of the either the major axis or the minor axis. If the number under x squared is bigger than the number on the y squared, it's the major axis. If it's smaller, it's the minor axis. But this number is the square of that number. So that means the major axis here is 4 long. Oh, okay, so sorry about this. It's from -2 to +2. Why is that? Because the axis from one end of the ellipse to the other end of the ellipse, that axis is 4 units long. So since this ellipse is centered on the origin, 4 units centered on the origin goes from -2, x equals -2, to x equals +2. Sorry about that little gaffe. So from -2 to +2, that's where the x's are going. Okay. So, anyways, let's bring the work back. Here's the work back. So the y is going. The y is the radius when x is from -2 all the way to when x is +2. That's where the ellipse lives. So that means the area of each little circle that make up that 3D ellipsoid figure, each little circle, each little disc, is made of an area which is pi r squared. But instead of r, okay, so I'll write pi r squared again. And instead of r, I'm going to put this whole y in there. Okay, so that means it's pi all this stuff squared. I hope you're not thinking all what stuff, but it's okay if you are, because if you are, I can just move this. There it is. All this stuff squared. My parentheses kind of got erased. Okay, my pi also. Can't erase the pi. It's going to be a National Pi Day or something soon, isn't it? All right, there it is. Area equals pi r squared, but the r is all this stuff. It's just y. And so it's really pi all this stuff squared. So what does that mean? That means, oh, silly me, I didn't really have to take the square root because I didn't really need y. I needed y squared. But that's okay. I can just undo that like this. Pi over pi times 1/16 times all this stuff. 144 minus 9x squared. So did you see this extra step that I did? I didn't have to really get y. I could have just solved for y squared, which would have been easier. The reason is y gets squared here anyways, because the r is squared in the area formula. So back here, you know, when I had y squared right here, right? Oops. When I had y squared right here, right there, I could have just left it right there. You know, didn't have to do the square root nonsense. That's okay. You still get the. I mean, it's still correct, right? It's just extra work. So there we are. A equals pi y squared. There it is. Now, that's just the area for one circle. Any one of those circles at any x. but I want to add up all of the circle.